Hey everyone, I'm Dominic, and I'm going to be critiquing this article. This is the Optimal Nutrition for Healthier Aging OptiAge study, a randomized controlled trial. The authors are linked there, and we'll be going through this today. Um, so the background of the study, so we're talking about osteoporosis, which is a reduction in bone mineral density, a BMD. This is a common issue affecting our aging population, and it results in fractures and morbidity and mortality. There's very well established research on the benefits of vitamin D and calcium on improving bone mineral density and preventing fracture risk. And there's been multiple associations of various B vitamins with bone mineral density in the research, but the mechanisms are not greatly understood. The authors of this study postulated perhaps the effects of B vitamins on one carbon metabolism could potentially play a role in regulating bone health. So here's just a quick summary of some of the current literature involving B vitamins and bone mineral density. So there's a couple cohort studies there. The Framingham osteoporosis study, cohort study in about 2,500 adults in America, and that showed an association of low B12 status with lower bone mineral density, in particular adults in the lower category of B12 status, less than 148 picomoles per liter, versus the adults in the higher B12 status group. Those with low B12 status had anywhere from a 2 to 6% reduced mean bone mineral density. The Hordaland homocysteine study, this was a study of 7,000 adults in a county in Western Norway. And this showed that higher homocysteine levels, which is a marker of potential low B12 and folate status, was associated with lower bone mineral density and increased fracture risk. There was some analysis of the US National Health and Nutrition Examination Survey. This was a study in 1,500 older American adults. And this also showed an association between homocysteine and B12 status with bone mineral density. And in particular, they found an odds ratio of 2, relating those with a B12 concentration in the lowest quartile when linked to osteoporosis or osteopenia. And there's some evidence in the literature that patients with pernicious anemia, which is a disease that impairs gut absorption of B12, can be at increased risk of fractures. And for example, there was a study here in which they showed 131 patients with pernicious anemia followed over 30 years. They were anywhere from 2 to 3 times more likely to suffer a osteoporotic fracture. B6 and B2 are much less studied for bone health, but they're associated with one carbon metabolism, and the authors postulate that these may share a similar role in regulating bone health. So just to give us a bit of clarity of what we're looking at today, so these are all the B vitamins. These are all water-soluble vitamins. And the ones I've circled are the 4 particular vitamins that are associated with one carbon metabolism that the authors have studied in this study. So you've got vitamin B2, riboflavin, vitamin B6, you've got vitamin B9 there, which is folate or folic acid, and vitamin B12. This is a really nice diagram that I've drawn from the Journal of Cell Metabolism, Cells, which shows one carbon metabolism. And obviously, it's a very complex network of biochemical reactions which are involved in one carbon metabolism, mainly important with various biosynthetic pathways, but with DNA synthesis and repair and antioxidant defense mechanisms. And so the main things to just point out here is that the green boxes show folic acid or folate and its derivatives. And so obviously the pathway revolves around folic acid B9. And the yellow circles you can see here represent other B vitamins. So you've got B6, B2, and B12, all as important cofactors within this one carbon metabolism cycle that can have various effects on cell metabolism. So the method of this study, this was a dual center randomized controlled trial in Ireland over a 2-year period. Participants were 50 years old or over, and they were excluded if they were taking a folic acid or a B vitamin supplement already, or if they had more than 4 portions of B vitamin fortified food per week. They were excluded if they were already taking B12 injections. or if they had any severe digestive tract diseases that would impair absorption. So they were really targeting an older population that would potentially have low B vitamin status. It was a double-blinded, placebo-controlled trial. There was 2 groups, and the participants were randomized into either receiving vitamin B vitamins, which was, as you can see here, the 4 different B vitamins: folic acid, B12, B6, and riboflavin B2, as well as vitamin D, as opposed to the placebo group, which received just the active placebo, which was just vitamin D. So both groups received vitamin D at baseline. The authors did this to try and show any effects of B vitamins independent of vitamin D status. And the doses they selected were just slightly higher than recommended intakes, but still within a dietary range which would be achievable with a routine diet. The pills were blister packed. Empty packets were returned every 3 months to try and ensure compliance, which seemed pretty good throughout the study. And the placebo and intervention capsules were identical in appearance and taste, so this is all pretty well done. Here's a quick rundown of the recruitment and allocation, and you can see they ended up getting about 100 participants in each group. And so you can see the way that they excluded a lot of potentially eligible participants because of high fortified food intake, or if they're already taking B12 supplements or injections. So really trying to target these older adults that probably already would have low B12, B vitamin status, although they didn't actually particularly check that in the blood work initially. And these are a few of the markers that they were looking for. So they measured bone mineral density at the start and at the end of the intervention. So they did the same with the blood work. So once at the start, once at the end after 2 years. DEXA was done to measure bone mineral density at the femoral neck, at the hip, and at the spine. A single radiographer evaluated all the scans. There was 81% completion rate, so pretty good. The baseline characteristics of both groups were pretty similar, so fairly adequate randomization. And this was reflected with the prevalence of osteopenia and osteoporosis combined together was similar in both groups, so 60% versus 64%. And so again, illustrates a pretty high-risk group that already have pretty low bone mineral density. Here's the results of the study. So what they did show was that when they did the blood work at the end of the intervention, they showed significant increases in all of the markers of B vitamin status. So serum folate, serum B12, plasma PLP, which is a marker for B6, all increased. And then some of the markers there of B12, so serum MMA and serum homocysteine concentrations decreased, which would show improvements in vitamin B12 status. So they showed that in the intervention group was very clear. Despite this, at the end of the study, after 2 years, the bone mineral density at all 3 sites in both groups decreased by approximately 1%, and there was no real significant differences between the 2 treatment groups. So both groups declining in terms of the bone mineral density at a rate that is comparable to other studies in this area. Afterwards, the authors did a subgroup analysis, and so what they did find is if they took only participants with a lower baseline vitamin B12 status, as indicated by either a low concentration there or a high methylmalonic acid, if they took out that subgroup of patients and they analyzed it, you can see this graph here shows that there was some statistically significant reduction in the decrease of the bone mineral density, particularly noticeable there at the hip. So the black bars showing the active, the B vitamin treatment group, and so less of a decline in bone mineral density compared to the placebo group. They did the same analysis for all of the other groups in terms of status of B6 or B2 or folate or homocysteine, and they didn't find any similar effects. So only the B12 group with low B12 to start with showed any improvement in the reduction in the rate of decline of bone mineral density. And they suggested that this could indicate an independent role for vitamin B12 in bone health. So some strengths and limitations of this study. The strengths of the study is they did try to target a high-risk population with a high rate that already had bone mineral density declining. That would be appropriate to see effects in based on probably having low vitamin B status. They gave vitamin D to both groups so that any changes they saw were independent of vitamin D status. It was a fairly simple intervention, so just the one pill every day, pretty low dropout rate. It was a RCT, it was double-blinded, reasonable follow-up time. They had a fairly appropriate methodology, so they used DEXA, which is gold standard for measuring bone mineral density. They had multiple biomarkers and blood work metrics to analyze the B vitamin status, including using a couple of different metrics for B12. So they use B12 and homocysteine and methylmalonic acid. So they've got a few different markers there. And their post-intervention analysis confirmed that the treatment group did have improved markers of vitamin status, so that they did get a good benefit in terms of what the intervention was trying to do. The limitations of the study, obviously it's a free-living RCT. I couldn't see any note of them having any real follow-up in between. So from what I can see, they just kind of gave them the initial workup at the start of the treatment, and then 2 years later they follow them up. And so there's multiple confounding variables that could happen in the 2 years that we can't really comment on. The intervention did involve 4 different B vitamins, so it slightly confounds the picture about which exact B vitamin is having an effect, if any, in the intervention group. They didn't select participants based on biochemically proven low B vitamin status. They did try to screen for those patients, but in the end, they only actually had about somewhere between 17 to 30% of this participants actually had biochemically proven deficiencies in one or more of the B vitamins. So not the most great selection of participants to potentially get the biggest effect. And the subsequent subgroup analysis they did for B12 was in a smaller population than they powered for, so a small sample size and reduced statistical power. So what was the aim of this study? The author's aim was to investigate the effect of combined low-dose B vitamin supplementation for 2 years on bone mineral density in community-dwelling adults. And what did we see? What did the study tell us? There is no real clear effect on routinely supplementing B vitamins for improving bone mineral density in adults with a baseline normal or borderline low B vitamin status. And this is despite showing increases in biochemical markers of B vitamin status. So despite showing that the supplementation actually was being absorbed by these people. Subgroup analysis shows maybe some role for B12 independently on bone health, but pretty small sample size, pretty low statistical power here, limits the usefulness of this. So where does this leave us? So the mechanisms of B vitamin effects on bone health still remain pretty unclear. And the authors here are trying to see if that's related to 1-carbon metabolism. So routinely supplementing B vitamins, all involved in 1-carbon metabolism, did not meaningfully affect bone mineral density in any way over a 2-year time period in this RCT. Whether there's any independent effects of B12 on bone health outside of 1-carbon metabolism, this is also pretty unclear. The authors postulated some potential mechanisms. So potentially B12 could affect some bone formation markers such as ALP and osteocalcin, which have been shown in some other small studies, which perhaps could show that B12 deficiency impairs osteoblastic activity, but this is not very well understood, and the study doesn't really give us any extra understanding in this area. So there's definitely a need for further studies looking specifically at the role of B12 in bone health, as well as improving our mechanistic understanding of how B12 impacts on these bone health metrics. Based on current evidence, there may be a role in supplementing those with low B12 status routinely to improve bone mineral density, especially because B12 is pretty safe and pretty cheap. But we don't really understand the mechanisms well, so potentially we could do this for those in a low B12 status until we understand these mechanisms a little bit better. Thanks.